To continue from the previous video where de-Broglie wavelength is given as h by p, which we wrote it as h by square root of 2m into kinetic energy, which can also be written as h by root of 2m into charge into potential across which the charge is accelerated. Now in this video we will write de-Broglie wavelength of a free neutron, and then we write that for an electron also. So what about the neutron? Suppose if one free neutron is there, it is able to travel along x-axis and y-axis and then z-axis. So a free neutron, it has 3 degrees of freedom: the energy along x-axis, energy along y-axis, energy along z-axis. So if a particle has f degrees of freedom, we know that the kinetic energy of the particle according to law of equipartition of energy is f times half kT. For each degree of freedom you get half kT energy, kinetic energy. For f degrees of freedom, f times half kT. A free neutron can travel along x, y or z axis. So basically a free neutron has 3 degrees of freedom, hence its kinetic energy is 3 times half kT is 3 by 2 kT. Hence de-Broglie wavelength of a free neutron equal to h divided by square root of 2m and kinetic energy here. So kinetic energy is f by 2 kT, here in our case 3 by 2 kT. Hence 2m into 3 by 2 kT is there. So 2 and 2 will be cancelled, which means that lambda of the neutron is h by root of 2 and 2 will be cancelled, right? So 3m kT. So this question has been repeated at least so many times in the exams, so in different kinds of exams. So de-Broglie wavelength of a free neutron is h by root over, as opposed to 2mk will be having 3m kT, where here T is the absolute temperature. T is the absolute temperature, means the temperature must be in Kelvin. So here T must be substituted in Kelvin. Okay, so we'll continue solving de-Broglie wavelength of an electron. So going by this word, if an electron is accelerated by v potential difference, what happens to de-Broglie wavelength of electron? H divided by square root of 2m. Q is the charge. We know that electron's charge is E and the potential is V. So I'm going to give you two versions of the formula, which is going to be useful in two different conditions. So this can be written as like H divided by, this is root over 2me into square root of v. Like that we can separate, which means that I take this up. So h divided by square root of 2m into electronic charge E divided by square root of v. So if you substitute h is Planck's constant, and once you substitute 6.626 into 10 power minus 34 divided by square root of 2, mass of the electron is 9.1 into 10 power minus 31 kilogram, and charge of the electron is 1.6 into 10 power minus 19 whole divided by square root of v. Let us keep it is accelerated by v potential difference. When you work out all the values, you will get 12.27 into 10 power minus 10 meter. So into 10 power minus 10 meter. 10 power minus 10 meter is angstrom. So angstrom divided by root v. So one useful form of de-Broglie wavelength of an electron, this is only for electron. So de-Broglie wavelength of an electron is 12.27 angstrom divided by square root of v. Suppose if v is, let us say they give it as 64 volt or 100 volt. So if it is a perfect square root, then you can use this formula. Otherwise there is another form also. So de-Broglie wavelength of electron, here from this we can write it as, you extend the square root to the entire thing. So it is whole square root h square divided by 2m e into v. Now if you substitute all the values, 6.626 into 10 power minus 34 whole square divided by 2 into mass of the electron 9.1 into 10 power minus 31 and charge of the electron 1.6 into 10 power minus 19 into V. So if you calculate all of it, you will get lambda of the electron equal to whole square root of 150 into 10 power minus 20 and divided by V meter. When you take that square root out, it is 150 by V into 10 power minus 10 meter, which can be written as square root of 150 by V into 10 power minus 10 meter is angstrom. So the other useful form of de-Broglie wavelength of electron, this is only for electron, for nothing else, that is why I wrote it as lambda E. So 150 by V angstrom. Angstrom is outside the square root. If they say let's say the voltage is the voltage across which electron is accelerated is 15 volt, what is the de-Broglie wavelength? It's pretty simple. Lambda of the electron is equal to square root of 150 by accelerating potential is 15 volt. If it is 15 volt, square root of 10 angstrom. Square root of 10 is roughly 3.1 angstrom. So this way you can do. If they say it is accelerated by a potential difference of, let's say, 100 volt, means so lambda of the electron is equal to 12.27 angstrom divided by root over 100. Root over 100 is actually 10, so roughly about 1.227 angstrom. So this way you can find the de-Broglie wavelength, the two forms of de-Broglie wavelength of electron, and this is the de-Broglie wavelength of a free neutron.